My name is Andrew McPhee. I'm a solution manager for industrial security here at Cisco. So I take care of the Cisco validated designs you may be aware of. So the architecture of how do we do security within industrial networks, whether that's manufacturing, utilities, roadways, etc. I'm the person who has to create those designs and then build those validated designs. And today I want to talk to you about industrial security specifically with NIS2 compliance. NIS2 is one of the very relevant industry standards, especially for this conference because we're in Europe. And one of the things I really like about NIS2, or one of the things that I appreciate about NIS2, is I've been preaching security for a long, long time, especially to industrial networks. And people always say security is great, we want it, but there's never really been a forcing factor to do it unless there's some compliance standard that's really forcing them to do so. And NIS2 applies to pretty much every industrial vertical that we have. When I work with customers in the US, let's say in utilities, there's things like NERC-CIP. When I work with railway customers, they have the TSA, or if it's on the pipeline, it's again TSA. But NIS2 is on manufacturing, it's utilities, it's wastewater. Every customer I speak to has this forcing function of, I need to comply to NIS2. What does that mean? And how can you help me do it? So there is a set of cybersecurity measures in place, about 10 of them. And it's not set in stone. It's not like a concrete list of you must do this. It's not a strict set of this is your requirement, you hit this and you comply. And we do need to wait a little bit for those member states to put it into law of what the specific entities and specific countries need to do. But I have highlighted some things in blue to say, what is it that we're going to be talking about today? First thing we need to know is what is the risk that these devices have on our network? How risky and what's the risk profile of my device? We're then looking at things such as supply chain security. Am I bringing secure components into my network, or do I have unmanaged switching, and do I have the devices that I may not even know about? What is the security posture of my network, and can I get secure components such as standards like IEC 62443, which has certifications on those components in this industry? We then have vulnerability handling. As a supplier, how are you in exposing the vulnerabilities that on your devices? When the threat intelligence companies such as Talos come to you and say you have CVEs related to a vulnerability on your device, how do we take that into a threat intelligence database and tell you what vulnerabilities exist in your network? And then finally, when we look at access control policies, the users that are in your network, the users coming in for remote access, are they using things like multi-factor authentication? These things are going to be complied with NIS2, or NIS2 is going to put this into compliance. We need to make sure we have the access policies in place in order to be compliant. And I'm kind of just going through these slides a little bit quickly because I mainly want to talk about demos today. I want to show you the products, I want to show you the capabilities, and you can see it for yourselves. What is it that we do? But the two products we're really going to be highlighting today is Cisco CyberVision, which is visibility of the plant floor. It's that deep packet inspection engine will let you know what assets exist, what are they doing on your network, and how vulnerable they are on your network based on those relationships and those vulnerabilities. So security within the OT environment, but then also secure equipment access, and that pivot to zero trust network access for remote access, and how do we solve the risk of entities coming in from outside the network, which is a huge attack vector to these networks. So we start off with a small introduction to ZTNA, what it is, what the product is, and then I'm going to go into a demo. Verizon does a data breach investigations report every single year. I'm still waiting for this year's report. It may have came out since Cisco Live. I haven't been keeping up with it. But last year, the 2023 version, we can see that 83% of attacks happened outside of the network. And of those attacks that happened and came from outside, the initial attack vector is traditionally some social engineering attack, which is attack on your people. And half of those involve stolen credentials. And what that means is the people in your organization are being targeted, their credentials are being targeted, not necessarily because the network itself got targeted, but the other websites that they may be exposed to, such as if I was to log into MyFitnessPal using the same credentials I use for my email and my work, then those credentials are also exposed. And we see that in some attacks that have happened in the past, such as Colonial Pipeline, which was involved stolen credentials.
And these statistics are across all market sectors, not only
these specific ones. Verizon does break down into different categories. So we could look in and look at manufacturing and isolation, or utilities and isolation, and you'll see a similar trend in which it is still external threats will be the biggest attack in the network.
So my customer view on that, in the OT industrial IoT space, the number of vulnerabilities and unmatched devices is much higher than in all the other things, because often there is no option to patch, or you have hard-coded passwords. And I think a lot of the problems we can document them and so on, but sometimes it's kind of, there's no native patch way available and so on. So the numbers are higher compared to other sectors.
Yeah, the numbers of vulnerabilities are certainly higher, but those devices are not normally the initial access point for an attack.
Yeah.
So the 5% number that we see here on the slide is the initial access attempt. So someone had to get onto your network, typically through a remote access gateway, or someone bringing in a laptop that was already exposed, and then they're going to scan your network from there, and then they take advantage of the vulnerabilities. So the first step, and this is what I'm referring to in this, is just how do we stop that initial exploit from occurring? And then you're completely correct, the internals, and we'll get to that with cybervision. How do we make sure that we can protect those vulnerabilities without patching? Because we can't patch all of the devices. Completely correct.
Is there an overview or a kind of a percentage related to IoT stuff, which is vulnerable or been hacked or attacked? Or
so I use the 83% as an overall number for that report. What we could do on those Verizon data breaches is just focus on the sectors that are, say, industrial focused. So you could take the same numbers for manufacturing, utilities. I think they also do pipeline, maybe railway, and I think maybe wastewater. I forget which categories they have. They don't have all the verticals listed, but you could take that data in a snapshot. It wouldn't be the exact numbers, might not be 83%, but it would be the same trend that we'd see in terms of the number of attacks normally come from outside the network, and then normally involve some sort of social engineering or some sort of phishing attack, usually.
They also do it in a really nice visual graph. So yeah, definitely look at the reports. They're quite
it's an awesome report to look at for sure. Looking forward to the next one. Well, not hopefully the trend. I assume the trend will still be the same going forward. So to address that initial access attempt and address that largest attack vector, Gartner didn't come up with it for OT, of course, but ZTNA is that pivot that we're seeing in the remote access world. The difference really between a VPN system and a ZTNA system, if I was to simplify it, is VPN gives you access to a network, whereas ZTNA gives you access to an application or an asset. And it's driven based on your identity. So as a user, I'm working this week in Cisco Live. I work from home in Ireland most of the time. There's an office in Dublin. Sometimes I travel to San Jose. I might work in a coffee shop. It doesn't matter where I am in the network. It's my identity that gives me access to these devices. And that's what we've been pivoting to in the IT side. But my identity is not giving me access to the network. It's giving me access to a set of resources in which I have privilege to access. And that's what we're doing with ZTNA in the OT as well. We would have had guidance previously, such as what we're seeing on the left-hand side, where we would tell users, you must VPN into the network. And we're going to do multi-factor authentication on that VPN. We might even do some device posture on that VPN. But we took it a step further in OT by saying, well, we don't fully trust your device. I don't know what applications are on there. I don't really want your device interacting with my critical systems. So we'll give you a jump server. So we put policies in place to say, you can go from the VPN to the jump server and nowhere else. And then from the jump server, then we'll put policies from jump server to target device. And that works, it's secure, we can do it, but a lot of operational overhead, because every vendor needs different access to different machines, and a different machine one day, then the different machine next week. So you're constantly changing policy over and over again. It's too much operational overhead, which means you end up leaving the jump server wide open access to the network, typically. So I'm not saying the left can't be secure, just a lot of work to make it secure. The ZTNA broker, on the other hand, is you put a broker in the middle of your network, and instead of having access to the network, you're basically route traffic to the broker, and that broker routes traffic directly to the app. And that's the only thing that you'll have access to. That's what we do in the IT side. I work from home now. I don't VPN into Cisco data centers. If I want to access Cisco resources, it's all through Zero Trust Network Access. It's widely used in the OT side, on the IT side. But there is tools out there to make it work on the OT side. So the last slide I'm going to show before showing this in demo format is just the architecture of how this works. It's a kind of two-tier approach, if you want to call it that, where we have a cloud element called Secure Equipment Access. It's actually hosted in a platform that we call IoT Operations Dashboard, if you ever see that word in our marketing, because we have multiple applications hosted there. But the users and the administrators interact with the cloud. So as a user, I go to the cloud for all of my access, but it's not exposing the critical network to the cloud. It's the SCA agent that sits on-prem. And we run it within our infrastructure itself. So you may be aware of our IEs and our IOR platforms running IOX containers. The SCA agent is just an IOX application. It is an outbound connection to the cloud, so we don't need to, expose it with a public IP address like we would with a VPN. We simply just send that connection up. We have that connection established, and then all of our interactions go through that broker. So rather than spending too much time talking about it in a slide, let me just demo the product. Okay, so this is IoT Operations Dashboard. You'll see is a US. We have both a US and an EU cluster, depending on where you are. And if I log in, and I need to get my phone out for this because I got MFA. My phone is in my bag, so give me a second. Of course. We'll log in. So I'm currently being redirected, as you notice. So right now, my access is actually being policed by an external IDP. And I am logged into that external IDP, but I'm getting pushed to my mobile. So give me a second. There we go. Just to show MFA, I actually need my device to get in. So there we go. MFA has been accepted. So we can do this locally. There is MFA local on the dashboard itself if all your user accounts are local, or in most customers use this, do this, already have. They have a single sign-on solution where they manage their users. The MFA that they are in place is already on that single sign-on. We'll just fit into that mechanism. So I go to my organization, and I'm an administrator, so I have a different view than a user would, but I can show you what that user view would look like. The dashboard just kind of shows us some administrative stuff. There's nothing really exciting here. How many agents are in my system? Are they up? Are they down? Etc. The interesting part of it is, what does the user experience look like for user access in the network? SCA is both client and clientless. So right now I have clientless access to the network. And if I go to one of my products, Cybervision, that we're going to talk about a little bit later on actually, and I want SSH access to Cybervision, I simply just click on this access and a SSH window opens for Cybervision. It's the browser making the connection for me, and I have SSH access to this device, but I'm not on the network. It's just the private session is built into that browser. Same on ESXi. If I needed to do some work within that lab, I could log into my ESXi system, and suddenly I'd be in the system.
In this context, how would like a SSH session into Cybervision, how would ZTNA there prevent lateral spread?
Great question. So if you're using access methods, such as I'm going to terminate my session to something that you could then move from, then yes, the lateral spread has to come from your existing LAN segmentation policies. So if you're accessing a device, let's say if you're doing the 62443 model of zone conduits, if you were to get access to one of your zones, that device probably has access to everything in the zone, and you're going to have policies for you to spread across the zone.
So you still rely on traditional ACLs or VLAN or
firewalls, whatever it is that you're already using for that zone.
Okay.
SCA is simply just getting you to that device. So we can still fall into, I won't call it a trap because there's legitimate use cases for this. I have a jump host in my lab today. I had it before I had SCA in my lab, which I used to get RDP connection. So I can do an RDP connection to this jump host. And again, my jump host is connected with MFA because I'm a security nerd, and I can get into the jump host in my lab and do lab work from there. So we can still use this for your traditional access of, I have jump servers, but I need a better solution to do access control. You could use that tool for this as well. Yeah. Now, the other thing though, I talked about is client-based access. And there's legitimate reasons why you might do client-based access, such as vendor applications that you don't want to host within your environment. So one of the, say, if you want to call it advantage of a jump server, is you could host the vendor applications on the jump server, and then they'd have all the tools they need to interact with those devices. But we've been met with use cases where, let's say in a traffic intersection, where we want to control the lane markings on traffic lights. We might want to dynamically allocate those lines somewhere else because there's roadworks happening. And traditionally, someone would go in a truck and drive to the traffic lights and plug their laptops in, make some changes, and then drive back to the offices. when we have secure equipment access there at the intersection, we can bring that vendor laptop in to interact with that device, but just have a single kind of session. So they're not VPN to the intersection, they just have a session directly to the application. And the way that works is a little button here called SAA Plus. And I have the SAA Plus app here, so I don't need to download it like it's asked me to do. And you can see there was a little, oh, of course. Okay, my security policies. All right, we're going to get a, looks like we're getting a Duo demo.
Like it works.
Yeah, we're getting a Duo demo at the same time. This is great, isn't it? It's in my IoT cluster. So my location is not set to Netherlands. So there we go. So this is Duo. So Duo sits in the back end of secure equipment access. Duo is our MFA platform here in Cisco, but it does more than just MFA. It does posture checks. It does things like checking the location that you're in clearly, and only allowing, let's say, trusted devices on the network. So if I go to the policies that I'm using on this device, I think, yeah, this is SA Plus. I need to edit this policy. I didn't plan to show this today, but okay. We're going to add the Netherlands to this policy. Here we go. Save. Perfect. And now SA Plus. And if it works, let the demo gods be on my side. Perfect. Now my users in the Netherlands can get access to the network. So unintentional demo, but at least you can see the value of what Duo is doing. So Duo has that set of policies of like, well, what is the posture of my device? Do I have the firewall running? Is there endpoint software on it? That problem of, I only want trusted users to get access over this SA Plus. I know all my users are US based, so I only let them on it. And you can see those, you might have missed it because I didn't highlight it and I should have. These SCA Plus things were grayed out. There's no access for me to get there. So if I want to access Cybervision over SCA Plus, I click it. And what that has done is actually just created a route on my PC to get to this IP address. So if I want to go there, 10.0.2.6, to 2.6.
Just one side question. So we built the trust to our friends from the Netherlands. Yeah.
Yeah.
They are now in.
Yeah.
But a bit still we want to control. Can you lock the command that now somebody's typing in? So a very common thing that I've been asked by auditors. Can you show me what these remote people have actually configured via this connection?
We can. We'll get to that. I'll show you how that works. It's, well, spoiler, session recording. So we can record the session, we can monitor the session, and that's how we would do it. We couldn't, let's say SSH say you can't type in these letters into a console. There's no way for us to do that. But we can monitor in real time what that person is doing. So an admin could look over the shoulder, and if they don't like what they're seeing, they press a terminate button and they'd lose contact.
Just the feedback on that, since we have this disclaimer for all the remote sessions, everything is recorded.
Yeah.
The people that are working remotely are much more carefully on what they do. Yeah. So that's also the second factor here. Yeah.
I never even thought of that. That's a good point. Yeah. If they know they're being recorded, because we tell them you're being recorded. Yeah.
We are talking about clients, right? About IoT clients.
Well,
Some way, or
so repeat what you mean by that. You mean
it's an IoT dashboard.
IoT dashboard, yeah.
So if I think IoT, IoT clients like sensors, actuators, or a combination of them.
It can, so we call it IoT operations dashboard because the group that we're in is IoT or industrial IoT. And traditionally, when we put in our solutions, we're putting it into industrial networks. We get this question all the time because most of the people we speak to both work on IT and OT. And it's like, well, could we use this in our IT networks? Of course. It's just, SCA just needs IP accessibility to the target device. If that is an IT device, it doesn't matter. If it's to bring vendors to do building management, or if it's to do vendors just to do any sort of IT maintenance on your IT side, it's okay. It was built as a vendor remote access tool. So if I need to give a vendor clientless access to my device, I just create that target in Cybervision. They'd come in, they'd click on it, they can do their work. And one of the things I haven't shown yet is, again, because it's more on the vendor side, is when we look at their access control groups, like here's all the people in my network who can access Cybervision. we can do things such as scheduled access. So I can say that you can only get access between this hour and this date because this is the maintenance window, which is the traditional OT use case. But in IT, it might just be, well, yeah, we're going to give you half-day access to do your job, but as a contractor, you're not doing anything for us tomorrow, so you shouldn't need access. We're trying to get rid of that always-on access that remote access solutions typically have by giving you time-based access in here as well. So I hope that answers your question, but it doesn't have to be OT devices. It can be anything.
Maybe I'm a little bit too much focused on IoT.
Yeah.
Because it differs in some way.
Mm-hmm.
And if you talk about IoT devices, and we can make the categorize it between sensors and actuators, or a combination of both. So in what way is there an overview that's related to sensors or to actuators or both?
Yeah, no, it's both. It's anything with an IP address we can access on this tool.
Because it's purely for management, right?
Yeah, exactly.
So in a sense, it is for IoT targeted, but in a sense, it's a privileged access management capability that you have. Yeah?
Exactly. Your traditional IT remote access tools won't have things like scheduled access. You're probably not going to record all of your IT users' interactions. You're probably not going to be able to look over their shoulder and terminate their sessions. It's very much, I have a vendor who I need to control access to and I want to give them. We just also happen to use this internally for our own lab access, and it's just useful for other things as well.
Has this got like an API that you could then link into some sort of ticketing system? Or
so I don't think as of today the APIs are there. It's coming in the release soon that we're going to have that kind of Swagger UI that you'll be able to see all the APIs you can use to interact with it. So it's coming in the very near future.
So as you folks are thinking about this from an IoT and OT perspective, the needs for integration, following up on the API question, like there's not the traditional IT need for integration with like service management tools, but with ERP systems and back office systems, are you guys having those conversations and figuring out how customers are going to use it for like manufacturing processes versus IT processes?
So we haven't had those conversations yet. They're good suggestions. The customers are more thinking of how they replace the jump servers in their network and how to get down to kind of critical systems that are typically have private IP addresses. That's where most conversations are today. And even on the IT side, we've had conversations with those building management that, their use case is, I traditionally have to give you a laptop to come in as a contractor to work on the building management system. And it's a kind of, administrative.
Yeah, there's been, there's always a laptop for the key card system. It's a laptop.
Yeah, exactly. So it's like, can we use this and remove that process? But to get to, those MRP systems, it's not really come up yet in conversation.
Do you actually secure the access into the levels 4, 3.5, 3, and 2 and below from here? How do you gain access into those?
Yeah, so as I said, the architecture that we're showing, where I'm doing all of my interfacing with the cloud at the minute, what we're seeing here, what you're not seeing, is I have this network device, which is essentially just an SA agent. This agent is currently sitting in my lab in San Jose, and I have that active connection between an agent in San Jose to this cloud. So this agent itself has IP accessibility to all of these devices. So the agent is able to reach my Cybervision on this IP, ESXi on this, FMC on this. And then I can further control what protocols can be used to reach out to Cybervision. I can only reach Cybervision using SA+, SSH, or a web app. But I could even restrict this further and say some users can have access over the web app, and my administrative users can use SA+ and SEA. So we can control things at a protocol level. It's not just this user group to this device. It's this user group to this device using these protocols we defined as administrators.
So that agent needs to run on a virtual server?
So it runs in IOX today. It's supported to run in our industrial Ethernet switching and our industrial routing platforms, but it's just an IOX agent. It's just a container. Yeah.
And this just needs an outbound connection to go back to the cloud platform, or what does it?
Yeah, we can give it exactly. Yeah, so we can give it multiple interfaces. So your agent could have an interface that is allowed access to the outbound, and then you could give it another interface to allow it into that private, or you could just have a route between down into those private IP addresses if you wanted to put more control, maybe at a router level. Maybe you want to force it through a firewall before for an additional level of control. It's up to you how you architect it. Manufacturing can do that, but top of a telephone pole. There's no firewall to get through, so we just do the dual interface approach. So
The agent-based approach can be applied also to unmanaged devices like a supplier, require administration permission,
So you mean the installation of the agent, or? Yeah. So the agent itself today is only supported on Cisco hardware, but from a technology point of view, it's a container. So there wouldn't be any reason from technology we couldn't port it to other platforms. But just today, from a support perspective, it's Cisco devices only.
Another question about the session against the OT environment. Is there a way, usually one supplier needs to manage an OT environment, manufacturing, whatever, may be required to do some file transfer, download or upload, for example, to upgrade a firmware of an actuator or to download some data useful for analysis, troubleshooting of their stuff.
Yeah, no, it's a great question. So today, there's not a support for, let's say, no special capabilities on file transfers. We can do file transfers through that SCA Plus protocol. If you were to create a session between your client and, let's say, a file gateway, we could open that up and we could send that file through. Today, we'd be relying on the posture itself of the device, that if we force the use of endpoint software on the client, there's some confidence that we'd hope that their endpoint software is not storing malicious files and not allowing you to have that malicious file. But we recognize that's an area that is needed an enhancement. So it's something that's been explored of how we can do that, offer another service that would take care of files, because Cisco does have Cisco Secure Endpoint, and we have it in things like our firewall, and we have the ability of doing
sandbox itself
exactly.
as well.
We have all of that in our infrastructure. We just don't have it linked for this specific product today, but maybe something else show up in the future. Yeah, not a product manager, so it's not a roadmap thing. No promises, but it's something that is we have the capabilities to do. Okay, but so that's pretty much it for ZTNA, because I want to be conscious of time as well. That there's another demo I want to get to, which is Cybervision, which is more on that LAN side, but. Yeah, essentially it's just zero trust network access to the OT network, both from a client list and then all those admin controls that hopefully came through well. So back to the presentation. And if we go to the next part of it, it's understanding your cyber risk with Cisco Cybervision. What Cybervision is really trying to do is trying to give you a risk analysis of your OT network. It's doing deep packet inspection within the OT itself. So what are the assets that are in there? What are those assets doing on my network? And try to get as much details about the device as we can, so we can then start matching vulnerabilities to that device. We're then going to use that asset discovery to actually implement segmentation in the network. So that'll be demo number 3 that I show. How do we use visibility to do control? Cybervision itself has 2 sensors. There's a Cybervision sensor, and then there's the snort sensor. So that same IDS that we have in our firewalls and Umbrella and other parts of our platforms, it's the same snort signatures we can bring to Cybervision to do snort intrusion detection within that environment as well. And then, of course, the vulnerability detection. So what makes Cybervision different from other tools? We're not the only one that does OT visibility. There's a lot of people that do it. The main thing is the architecture. We are a networking company. And as I mentioned before with SCA, we have the ability to do IOX application hosting. And Cybervision is another one of our IOX applications. All of the deep packet inspection happens locally within the switch that it's connected to. So rather than doing span and having to tap all of the network into additional hardware, paying for more cabling, more boxing, having to do power and cooling, and all of the overhead and the management that comes with having boxes on that plant floor, Cybervision just resides within the existing infrastructure. So if you're using Cisco switching, you'd put Cybervision sensors in the application of let's say an IE3400, which is a DIN rail IE switch. And then it's still span, but you span to the application. So no additional cabling needed, and we're not in the path. We're not going to stop critical traffic from communicating. We're not going to slow it down, create any jitter. It is just a copy of the traffic. And that's why I mentioned that snort is an IDS. We can't put it in IPS mode. We can run it in things like the Catalyst 9300 because it has the extra compute to do an IDS. but it's just a mirror image. So we can only give you those alerts. We can't get you that blocking. But we'll get to how we do segmentation in a little bit. And I'd rather just show all of the capabilities we have in a demo, but this is something I can't really show. So Cybervision has two parts to it. There's the center, which is what you're going to see whenever I get it back up on the screen, and then the sensors. So the center can be a hardware appliance, or it can be a virtual machine, or we can even host it in the cloud, both in your private cloud, and we're also developing it as a SaaS application as well. And the sensors, they're the things that collect the data and do the DP. It can be metadata between sensors and cloud, but all of that processing happens locally. So if you're running it in an area where maybe there's some restrictions over a WAN, like utilities, where I can't afford to stream all my data back because it costs money to go over cellular, we're only sending metadata back. It's about 2 to 5% of the total amount of data we see. That's what we'll send back to the center.
Do you use Snort2 or Snort3 in this engine?
Good question. I think it's either Snort3 is either there now or it's coming. I got asked that question this morning. I haven't had a chance to confirm with engineer if it's Snort3. I believe it's Snort3, and if it's not, there's probably someone on the other end of this camera screaming at me. But I think so. Yeah.
And just maybe you can give us some insights. It all falls down on the Snort engine or on any IDS that you have good rules that are matching IoT. I guess a lot of the people that are using Snort for, let's say, traditional IT landscapes, they are more interested in Windows-based stuff and so on. For that, I assume you need a lot of special detection policies that cover IoT and OT use cases.
We do, and we're very lucky to have Talos Threat Intelligence be that kind of engine for these rules. Talos is one of the kind of largest threat intelligence agencies in the world, and we have a huge amount of OT rules thanks to what they do. If you've ever worked with our firewalls, you go to FMC, we have a whole SCADA category dedicated to OT rules. And the Cybervision sensors themselves, there's additional work we put in place that a lot of the rules get filtered out and are never used by Cybervision because we know they're not relevant to the OT industry. So rather than holding a huge signature file that is meant for your internet boundary, a lot of those rules are filtered, both on Snort can be done in two ways with the community rules, or we have the Talos rule set, and both those rules get filtered down. So it's only using the rules that are OT specific.
So I guess it's a license subscription to get the premium feed so that you get...
Yes, exactly. Additional licensing for the Talos rule set. Otherwise, it's community. Yeah.
The signatures, having signatures for the OT is a good point. But, on the OT, there are a lot of protocols, proprietary protocols sometimes, like example, Siemens, and so on. Do you deploy some dissectors for Snort to able to understand how it works, the protocol, and then detect potential threats?
Yeah, so it's a proprietary protocol, and we haven't worked with that vendor before. We don't have the signatures for it. And then it would be a question of, is there vulnerabilities or is there things we can detect within a proprietary protocol that would signify that there is a detection? We can do custom rules. So if someone, we were working with a customer and they understood or wanted to work with their vendor and say, we want to detect more about your proprietary protocol, we could load custom rule set in there that would match, but it wouldn't be shared then as a part of that knowledge database. So.
Okay, so customer can customize.
They can customize.
On it.
Yeah, if they're familiar with writing Snort rules, they could upload their own lists to it as well, for sure. Yeah.
Does this build up a device inventory as well? Does it build up a device inventory as well?
The Snort part doesn't. That's what the Cybervision sensor is for. Yeah. So I can open up Cybervision and continue with the questions, but some of them may get answered as we look at the product itself. So just refresh the screen so I'm all logged in again. Let's go and refresh this one as well. So this is Cybervision. This is the center, at least, of what you'd see. So as you are logging in and want to know what is on my network, Cybervision Center is the place for that. And I'm probably jumped ahead just a little bit. If I go back to this Explore page, one of the problems we have in OT, well, it's not really a problem, just the realities of OT, is the number of devices that we have in the network is quite significant. So from an asset inventory perspective, I don't want to see all of those devices in one go. I just don't have the brain capacity to be able to look at a list of 2,000 devices and understand what it is I'm looking at. So we have this concept of presets. And a preset is a way for you to just look at a snapshot of your network at any one time. So all of the devices and all of those communications get stored in a database. And then you'll build presets to say, well, I only want to look at this snapshot of my network. Or I only want to look at activities that go towards the public IP address. Or I only want to look at the DNS activity because I want to see what DNS servers exist in my network. So you can create those presets, and then depending on your focus area, and depending on which user logs in, they might want to see different things at different times. And this is just a small demo environment, so we're not going to have lots of devices in there. It's a lab that we have with a few PLCs and from Rockwell, from Siemens, and then just some Windows devices that are there to control them. And I'll actually start off on the device list view. This is everything that we know about a device. We can see that this is a Rockwell controller, L16ER. We have a Windows workstation. There's a Siemens PLC. Usual IT stuff, first activity, last activity, IP address, MAC address. And then we get down to this risk score. So if I just take any one of these devices and I look at the technical sheet, you can start to see the things that we would have learned through this passive discovery. So we have these normalized properties, which is our way of trying to take all of this detailed information on the right and giving you some sort of normal view of that, because we can say get the model name from multiple different protocols, but we only want to show it once, which is our normalized property. But this is how it works. As Ethernet IP is communicating between the PLCs and the I/O, or maybe the maintenance stations and the PLCs, we just continuously read the traffic, and we'll see things such as the name of the device, the serial number of that device, the status. So, you know, this one, it was in run mode. It's Rockwell Automation, the versions that we've seen. So when we first saw it was this version, now it's up to version 5. And we'll give you that, the properties of the device. What is this device? We do that for every single device in the network. The PLCs, the I/O, the Windows station, your network infrastructure services. And we can put all of this into a map view. What are these devices doing on my network? And the reason why this is important is because when we want to do things like segmentation in these environments, especially in a brownfield environment where we've not done segmentation before, it's important to understand the relationships that these devices have now, and then confirm if those relationships are normal. Because in many cases, things have been misconfigured, or communication is happening that I didn't even realize was happening. It's not causing downtime. It's not really malicious. It's just wrong. And that's either true misconfiguration, or maybe even some poor routing configurations, or I expected things to come up through this router, but it turns out the OT team were like daisy chaining PLCs and they're all connected together. And I'm just seeing some things that just don't make sense. And there's an opportunity for you to kind of clean up your network a little bit. Let me find out what's there. Let me find out what it's doing. And then let me create that zones and conduits model that we talk about in 62443. But before we get there, because it's NIS2 compliance and it's risk, what do we mean by that? We mean, how vulnerable are these devices to my network? What vulnerabilities exist based on those device profiles? And we can look at this in 2 ways. Just give me a list of all the vulnerabilities, and if there's a vulnerability I was interested in, I could search for the vulnerability and say, does this thing exist? We see things in the news all the time where this new CVE is terrorizing manufacturing plants. Does the CVE exist? Which devices have it? Well, what do I need to do today? What's my immediate reactions?
So no, am I vulnerable?
So what do you mean by am I vulnerable?
Well, because some vulnerabilities might be, this version is vulnerable, but you have to have this feature enabled or something. Would it have that broader context?
Not to that extent. So I'll show you in a minute. If I go to one of my devices, so if I take, we'll take this one as an example. I want to look at the risk score of this device. The risk score is built on vulnerabilities, activities, group impact, and what device it is. The vulnerabilities themselves will come from things like you're this vendor, you're this, let's see if we'll go into one of the vulnerabilities to see if I can find one that matches well. I'll go with this, maybe, does it say? It's not giving me the version. Okay, yeah, identified vulnerable because of ENET version 31.3. So some of the vulnerabilities we will have got because you are below a certain version. And if you're above that version, that vulnerability disappears. Then the question you asked, though, what if I turned off the web server of a PLC? We don't know if the web server is turned off. We know that we haven't seen HTTP traffic. So yes, maybe we could hide that vulnerability because there's no HTTP, but the web server might still have been enabled. We just haven't seen it yet. Now, you could go to that vulnerability yourself and you can say, I'm going to acknowledge this. Web server disabled. And then it's acknowledged, it's removed from the database for calculations.
Oh, nice. Okay, cool.
So that risk score would adjust because you're like, well, this doesn't apply. And maybe it wasn't because the web server is disabled. Maybe it's like, my firewall rule, it's okay. And so you'll have your own reasonings. We'll still keep it in the database, but it'll be acknowledged in the database and who acknowledged it and why they acknowledged it. So yeah, it's some more self-customizable. But the things we can detect is it no longer is that firmware version, that's just removed the vulnerability.
Go ahead.
Sorry, could you adjust the risk score as well to take into account mitigating controls, reduce the risk?
So that's kind of at the vulnerability level, yes. So there's two things we can do to manipulate our own risk score. And if I go bring the risk score back up, there is well, technically three actually. So because it's the vulnerabilities themselves. So it's all of the vulnerabilities that exist will kind of aggregate into a percentage of how risky this device is. If you can remove those vulnerabilities, either through patching a device or by acknowledging vulnerabilities, then that part of the risk score is going to be reduced. The activities then also contribute to risk score. So if we're seeing some insecure activities, like it's an insecure protocol outside of it being an OT protocol, then that might be insecure. Like we've seen, telnet to this device or whatever it is, that we'd flag that. So if you stop that from happening, then that would reduce the risk score. The last one then is the group impact itself. So whenever we looked at this map, I'll go back to the map view just for a second. We can see that we group devices. So this is my plant, and this is a manual group that I've done. I said that these are my plant devices, and these are my devices in line 3, and we can see it's a high impact group. Line 2, I believe, is also a high impact group. Because we've classified those devices as high impact, that's increased my risk score. Now you said, what if I have mitigation in place? One of the things I'm going to show in a later part of the demo is, well, if we build our zones and conduits model in CyberVision, and every one of these groups is a zone, and I know I have mitigating factors for that zone, maybe it's no longer a high risk group. Maybe you could reduce it down and say, technically it's still a critical group, but I'm going to make it a lower risk because I know that there is protection controls for it, and that would then reduce the risk score. But this zone, I don't have any mitigation factors for. I need to elevate that because if something gets exploited, I know the blast radius is wider. So they'd be the type of things you could do to control it.
Okay, thanks.
Yeah.
Any plans to integrate this with Scanner? So because this is kind of the Cisco advanced risk scoring, yeah?
Yeah, great question. So CyberVision has two flavors at the minute. There is a SaaS version that we have in IoT Operations Dashboard, and then this is on-prem version. And today they are two separate products. They do the same thing, kind of, that on-prem has more features, but we're developing it in the cloud. So the cloud version today will give you that asset inventory, but it doesn't give you communications. You can't build maps, but we're getting there. But what we have done in the cloud is do the Kenna integration. So if you're integrated with Kenna, you won't probably look at the CyberVision risk score. You look at the Cisco risk score, or the Kenna risk score, as it's called, because we can actually send the CVs across and get maybe a more accurate risk score or more accurate vulnerability score for the vulnerabilities in that network.
So similar like to secure endpoint or so, you integrated the score, you can see it directly there. Then maybe it's also linked to the Kenna portal.
So we've only done that in the cloud today, but it will come to the on-prem in the future. It's just Kenna as a cloud product, Cisco in the cloud is a kind of easy integration. A lot of times CyberVision is deployed on-prem with no real connectivity out, but we'll work on that in the future. There will be an option to do it, just not yet.
And I guess for some customers, this is totally working fine. And other customers want to have a more advanced view, and then they have maybe the additional Kenna integration.
Exactly.
As well,
Yeah. Exactly right. So then the other thing we do, so we have a map of what's happening in this network. This is a snapshot of what's happening in my tiny little plant. But like all things security, we don't really want to spend hours every day looking at the tools to see what's going wrong. We want to know, well, just tell me what's changed. Is there something I should look at now versus something that just exists, but it's not really that critical? And you'll have certain standards that say, okay, well, we need baselining. So every one of these presets that we create, we can build a baseline for. So this is my plant baseline. So anything that changes within the preset, let me know. Any new internet activities from the internet activity baseline, let me know. If a new DNS server pops up in my DNS server preset, let me know. And there'd just be different presets with different alerts. And we simply just say, well, what has changed in this since you last saved the baseline? Any new devices? Has any of the device properties changed? Any new activities? And it just allows you to say, okay, well, what's new and is this okay? So I can click on this and of course it's giving me an error, demo God's not on my side. We can see that there is more context to this model reference number. It's not really a big deal. So I can just acknowledge the difference and say, yeah, that's fine. I'll just say, test, acknowledge and include. And now that is just part of the baseline and it's not going to alert me anymore. That goes away. So sometimes legitimate new devices get introduced. You just want to acknowledge this is a new device, add it to the baseline, get on with your day, no longer going to get alerted. But then sometimes a new device is something I need to take care of. That new device popping up means I need to raise an alert. I need to get on the phone with someone. What is that device and why is it doing a port scan on my network? That's what the baselining allows you to do. We then have the reports. So everything that you see as well can be created as a PDF report, and I think there's already one generated. So if we kind of look to see what a typical security posture report would be, it's just a PDF format that we could send, and maybe every week or every month you'd send this to a relevant party to say, here is a kind of snapshot of what's happening within your network, and is there anything that you need to deal with? Different security insights, how many critical vulnerabilities are in that network, and then maybe if you can use that to say, is it going up? Is it going down? Last week's report, you said there was only 20 critical devices and now there's 24. What's happening here? So we have that reporting structure in there as well. So that's
to detect like firmware upgrades and PLC stop commands and maybe block those or.
So detecting yes, blocking no, because Cybervision won't block. But yes, if we'll see things at a protocol level, so we'll see so again, back to the baseline, going to be highlighted. This workstation normally only reads variables from the PLC. Now we're seeing write. What's that about? This device normally writes to a certain register in the PLC. Now it's writing to a different register in the PLC. I'll highlight that. And then yeah, program uploads, stop resets, all that would be detected as new. Yeah, for sure. And then still kind of focusing on Cybervision, but taking that visibility and creating action with it. NIS2, as I said, it's not a complete standard just yet. There's 10 cybersecurity requirements that that has to be within the member state standards. But one common thing I keep hearing from anyone who's like closely following it is that 62443 is going to be part of NIS2. It's going to be one of those things that gets referenced. It's if you're using 62443, you're probably going to be compliant, plus things like the reporting that you have to do, plus things like the MFA, which I don't think 62443 does, but there'll be additional things. But if the baseline of your security is based on 62443, you're going to be in a really good position. And 62443 has this architecture called zones and conduits. A zone is just a collection of devices that you've decided belong to a process and also have the same security level. And a conduit is just a communication channel between zones. Normally switches, but it can be routers, could be a firewall if you want that level of control, but it's a network access device. And the intent of 62443 is just identify your assets, put them in a zone, and then put enforcement points in the conduits themselves. And what I like about kind of these industry standards is they all sort of just copy from each other, and they're all saying the same thing. So like NIST has zero trust guidance, they do micro segmentation guidance, all of the buzzwords we like to say in security. And NIST will say place individual resources into unique network segment and use switching, routing, firewalls as enforcement points. And they're basically saying build zones and define conduits. It's the same language when you get into the details of what is zero trust using microsegmentation for OT networks. And in Cybervision, what we wanted to show is that zones and conduits view. If you get that asset inventory, but then you group it in a way of how would I like to segment my network? I want to put this set of devices into this process, and then I'm going to create a group for another process, and those devices belong there. And I'm going to visualize those conduit channels between them. What is the relationship between process A and process B? And do I want to allow that in policy, or do I want to go back and block that? So what Cisco does from an industrial security point of view is that all of this is built in the network and infrastructure. When I showed you secure equipment access, remote access agent was built on network infrastructure. It was on the router or on the switch that you're already using in the network. The visibility is gained on the switch itself, and then the segmentation can also be fed back into that same switch. We use that with Identity Service Engine. So Identity Service Engine is a AAA tool, authentication, authorization, accounting, that we use to authenticate people and devices to the network, and then they give them their authorization policies of what those things can do on the network. And the biggest challenge we really have in the OT space is how do we know which privileges to give to which devices? Because we don't really understand what the device is and we don't know what the device is doing. But Cybervision knows all of that. So Cybervision can be that interface into, well, what is this device and what privileges should it have? And I'll show that in the demo. Before I get to the demo, I just want to talk about one technology for those of you who are not aware of it, and that is SGTs. I call them security group tags, probably because I'm in security. You'll hear some of my colleagues call them scalable group tags. I actually don't know which is the right answer. I'm going to keep calling them security group tags until someone gives out to me. But we're at this conference, so I'm not wearing my lanyard anymore because I was told to take it off. But I wear a black lanyard around my neck because I'm a speaker. Most attendees wear blue. A lot of our help staffs wear an orange. Very quick visual way to understand what role we have in this conference. Security group tags work the same way. It's just a small tag on traffic that says this is the role this person has in this network and infrastructure.
Policy-based.
Policy-based, yeah, it's just role-based access. And the SGT itself is just an identifier. Our switches can use it for enforcement, our firewalls can use it for enforcement, competitor firewalls can use it for enforcement. It's an open standard that just identifies what role you have. And then the conduits, which in the case I'm going to show you is the switch, can say, well, you're not allowed to go to that zone because you're in this group and you're trying to go to a different group and this ACL says deny. And that's what I want to show in the demo.
How would this work? Often in industrial networks, cells get delivered and put in place by system integrators with their own native switches, can't really touch it. And so with security group tags being enforced at the destination instead of the source, how do you deal with that?
Yeah, I wish I had the slides in here to actually show it, but I just done a segmentation session this morning that I should have pulled a slide in for. So there's a misconception with TrustSec, because we normally use it in IT, that you have to have a full Cisco network for it to work. Because TrustSec, as you just said, on ingress of an access, you classify, and then destination, you do enforcement. But it doesn't have to be in the access switches. So if you're not doing Cisco at the access, but you're doing Cisco in your distribution and your core, well, your ingress can be that catalyst that you have in your IDF, and then the egress is just when it leaves the IDF. So you make your TrustSec domain be higher up the stack. So your zones will become larger. So you'll have maybe a production line that then goes into a catalyst, and then they go to the next production line that's going to come out of a catalyst. But then SGTs can just exist within the catalyst. So you do line 1 to line 2, line 3 to line 4, and all of your policies are in the catalyst switches. Now, if you want to extend policy and go even further and make smaller zones, then you'll do things like Cisco IE3400s. And maybe you'll aggregate switches. So maybe the access is still not Cisco, but the aggregation switches are Cisco. And you create smaller subzones within those larger zones. And you keep working down. If customers have got IE3400 switches all the way down in the machines, it's possible for them to do segmentation down there. Is it needed? I'm not so sure. Because if you take one component off of the production line is probably going to go down anyway. So why would we isolate it in the first place? So we try to isolate at a process level, and then depending on the switch that process comes into, that's where we'll start the enforcement of our network. So.
I guess a lot of people are already happy if they can, let's do macro segmentation, at the gateway level. And of course, it's better, more granular you are, but it's better than you have to start somewhere,
Yeah, exactly. So OT is typically so flat and unsegmented, just anything, just to get them started. So there's some customers that's like, we don't have any switches except for the core. And then we'll start at the core switch. At least your core switch is segmented, and then maybe you'll get down to distribution.
The typical OT, the whole facility is 1/16. Everything runs in it,
Exactly. And they can't carve out additional VLAN. So security group tags, it still needs to be layer 3 traffic, but you can do intra VLAN segmentation using those group tags. So, so
aren't you missing some X or something to drop it, or?
No. So in this case, I'm actually allowing it. So SGTs only carry the source tag. So in the traffic itself, you don't see the destination tag. that switch that is doing the permit needs to know that that destination robot is HTTP5, and that'll be saved within within the switch itself.
Okay.
Yeah.
Yes.
But no, it's a good observation. So.
Thank you.
Yeah. Okay, so demo. So I showed here in Cybervision that I have a set of groups already enabled. And if you notice, it was plant, line 3, line 2, line 1. So, you know, those names are important. So if I go to Identity Services Engine, all of the information we see in Cybervision is being shared with PXGrid. But the important one, because we're trying to make things simple. We could go down the route of device profiling and say, well, I'm going to use things like, well, if this is a Rockwell PLC with this model number, I'm going to profile into its special device profile. I'm going to do authentication policies based on that. But another way of doing it is just saying, well, you've already created the groups in Cybervision. Why not just use them to create SGTs and ICE? So I probably need to zoom in. Unless it's coming up on this screen and through the video, okay, but a little bit small. There we go. Does it let me? There we go. So we can see all of our connected devices in the network based on their MAC address, and we can see the endpoint profiles. So the endpoint profiles is simply I just have a one-to-one relationship between a Cybervision group and an endpoint profile in ICE. So if you belong to this Cybervision group, you belong to that endpoint profile in ICE, and then we can use that during the MAB authentication session to give it an authorization policy. So, going too fast. If you're in the plant group, you're going to be given the plant endpoint policy. So if I pick any one of these in Cybervision, so we'll go back up to my MAC addresses just so I can see which one I'm looking at here. 3.30 is...
It's kind of still the best we can do, yeah? So certificate-based, I guess,
no,
not so much supported, yeah?
Not supported. So we take, we'll go -70, -07, this one -07 here. Yeah, so this one here, we can see it's the endpoint profile plant. So I'm just picking any sort of random one. So -07, we can move it. So right now it's in the plant group. Let's say I just want to put this into line 2. So I'll move it in to line 2, press OK. And I could refresh that just from a visibility perspective. So if we go to ICE and we refresh this, our -07 MAC address now has the endpoint profile line 2. And if I come over to the policy that's in place, the authorization profile is line 2. So what that does from an ICE perspective is a change of authorization. So when that PLC first plugged into network, or sorry, workstation I just done, when workstation was first in the network, it was part of plant group. So it was given the SGT for plant. Or it might have got a static SGT. You belong to this subnet, so you're getting an SGT based on the subnet you're in. There's multiple ways we can do this in ICE. But we want to elevate its privileges or change its privileges in Cybervision. So we do a change of authorization request, which will then result in getting a new SGT and inheriting all of the policies. And the reason that's important is new devices that come into the network. We don't want OT engineers to deal with IT tools. I don't want you to go to ICE or DNAC or whatever you're using to control your TrustSec. You plug a device into the network. It's a new device in Cybervision. I move it to my IT controlled infrastructure groups, and it just inherits the policy IT's already put into place. So Cybervision becomes that OT tool for assigning devices to security groups without OT engineers using those security tools at all.